All right, let's look at another example of simulating a random process. We mentioned the idea of drawing cards from a deck, and that's something that is a little bit trickier to simulate, but it's not all that bad. And so in this video, we're going to actually go through the process of setting up a simulation for a deck of cards, as well as you trying to use that to answer a question. All right, so the basic idea for simulating draws from a deck of cards would be defining, first of all, some sort of matching up between the actual values that are displayed on the cards and some numbers. So one way to do this is to just assign an integer value from 1 to 52 to each card. So you could say ace of clubs is 1, ace of diamonds is 2, ace of hearts is 3, ace of spades is 4. That would be one of many ways to do this. And in that case, you could then think of a deck of just the numbers 1 to 52. And if you want to then draw a card, then that amounts to choosing a random number that is in the deck, right? A random number from 1 to the length of the deck. And given that number, we can then pull out the value stored in that location. So in this case, when the deck is full, generating a number from 152 would just give us, well, that number, the number 1, well, the card in location 1 would be number 1, so that's not very interesting. But if we've already removed some cards from our deck, maybe the deck has only 40 cards in it, then we could pick a number from 1 to 40 and then pull out the card stored in location 40, and that would be what we have drawn. Okay, so we can do that with replacement or without replacement. And then if you want to then remove the deck, that particular card that you've drawn, you could just say deck parentheses n. So the card in location n is now the empty vector. And essentially what it will do is cut out that entry from the vector. And so the deck will get smaller. It'll have one less entry after the fact. Okay, so that's the big picture. That's how you can simulate draws of cards from a deck. And so let's think about this question that I asked earlier on. How many cards did you expect to draw from a deck before drawing 2 kings or queens? And let's write a code to actually do that. All right, so we'll start from, again, a blank slate here. So the question is, how many cards should you expect to draw before drawing 2 kings or queens? All right. Now, the first thing to note is that how we number our cards is completely up to us. We could number them starting with aces, but we could just as easily start with kings. And so I'm going to assume that numbers 1 through 8 correspond to kings and queen, since that'll make my the questions I'm going to ask in a little bit later on a little bit easier. All right, so if I draw a number between 1 and 8, I'm going to say that's a king or queen. If a number is not between 1 and 8, then it's not a king or a queen. All right, and so then let's start by initializing our deck. Our deck is going to be numbers 1 to 52. And then we would like to generate a random card. All right, and so the random card will pick a random integer from 1 to the length of the deck. And this is going to give us the location of the card, not necessarily the value that's displayed on the card. So I'll call that card loc for card location. All right, and then once I've got the location of the card, I'd like to pick out the actual value of the card. So card value equals deck of card loc. Okay, so at the particular location, I want to actually pull out the number that's stored there, and I'll put that in a variable called card value. And then after that, we want to remove that. So we would say deck of card loc. So the card that we pulled out is now gone, and so the deck is smaller. All right, so that would be the process of drawing a single card. But what I want to do is I actually want to repeat this multiple times, and I want to keep repeating it until I have 2 kings or queens. All right. So first thing I want is to keep track of how many kings or queens. So I'll call this K or Q. And initially I have drawn 0. And so we'll want to continue this task while that value is less than 2, because once we've drawn 2, then we can actually stop repeating this. All right, and so now we'll first pick a random location. We'll pull out the card value. We'll remove it from the deck. And then the question is, was it a king or a queen? And so we'll say if card value is less than or equal to 8, then that was a king or a queen. And so we'll want to keep track of that. So we'll want to increase our count by 1. All right, and if it wasn't a king or a queen, then we don't have to do anything. The count will stay the same. And if I stop my loop there, then I can just display the value of that variable. And so let me actually show you the card values each time. And this will be our card simulation. Save the file. All right, so we run it. And you see we first drew a 1, so that was a king. Then we drew a 17, 51, 47, 49. And then the second time we draw it, K or Q became 2, and so we stopped. Awesome. So we simulated drawing cards until we got 2 kings or queens. Now what we want to do is figure out how many cards is it going to take to do that. And in order to estimate how many cards on average we have, we need to actually be able to keep track of the flips, or the cards drawn. So let me find a variable called draw count. And initially we haven't drawn any, but every time I draw a card, I will update that draw count by 1. And then at the end, since I know that actually at the end I will have 2 kings or queens, what I'm really interested in is, what is the draw count? So let's try that again. Oops. Capitalization is important here, so I used uppercase instead of lowercase. So let's make that consistent. And now we'll see, okay, we drew no kings or queens up to right there. We got a 1, and then we got a 2. So at that point, it was our 12th draw where we got our second king or queen. Okay, so that's one experiment. Now, as before, once you've got one experiment, you want to repeat this many times. And so first of all, I'll define a variable results, which is going to store all of our draw counts. And then I will use a loop for the number of experiments. Let's do 100 for now. So for k equals 1 to num experiments, we're going to repeat this task. And it's important that we have this line dec equals 1 to 52 inside this loop. Otherwise, we're going to start having removed some kings and queens, and that's not good because we're interested in repeating the exact same experiment each time. All right, and so we'll restart the deck each time. We'll restart all of our counts. At the end, what we'll do is we'll want to remember the draw count. So results of k equals draw count. Or you could also say results of n plus 1 is draw count, as I did in the last video. Both would work. And at the end, I can print I can do results. I can do the mean of results. What's the average number of draws? And I can also do a histogram of results with some labels. The number of draws will be the horizontal axis, and for the vertical axis, we'll have the frequency. And let's do just 50 bins instead of the default, which is I think 10 or 20. All right, we'll see if we made any mistakes there. Looks like not. Okay, so results, it says at the end, it took 10, 11, 29, 7, 9, 22, and so on. But on average, if you average all of those outcomes, it took 11.8 draws. And if we look at our plot, we'll see, well, that's interesting. Okay, maybe that's a little more than we need. Let me turn down the number of bins. In fact, we'll give it a range. We'll give it 0 to 50. And what that's going to do is kind of create bins that have endpoints of 0 and 1, 1 and 2, 2 and 3. In fact, let me change that a little bit. Let's do 0.5. by 1 to 50. And so the boundaries of our bins will be 0.5 to 1.5. So if it took one draw, that'll be 1 bar. If it took 2 draws, that'll be another bar, and so on. See if that worked. And all right, that looks a little bit better. So it looks like we never, of course, got 2 kings or queens with 1 draw, which makes sense. It takes 2 draws to do it. We did have it happen once where the first 2 cards were kings and queens. It happened 6 times where the third card was the second king or queen. And then the most common outcome here, it looks like 10 or 11, actually happened 10 or 11 times that we got exactly that. And if we wanted to get a better estimate, I don't want to see all 1,000, but we'll do 1,000 experiments. We could do the same thing. And all right, there we go. So with 1,000 experiments, oh, it's still going. So it looks like I forgot some semicolons in there, and so it was taking a little longer to run. So let me retry that without the semicolons. All right, so there we go. I took on an average 11.4 trials, and if we look at our histogram now, you'll notice it tends to be a lot less jagged, a little smoother, and it looks like that the most common value is maybe around 7 or 8, but the average value is 11.4, and that is due to the fact that, again, we have this long tail. So every once in a while, it may take 30 draws before you get your second king or queen, but most of the time you're going to get your second one in the first 10 or so. All right, and as you'll see, as you turn up the number of experiments, that curve should get smoother and smoother. And by curve, I mean the top of the histogram. It may take a little while to run here. So here I'm running at an octave, and it's still thinking, it's still doing the experiments for me. But eventually, it will finish, and it will display a histogram that should be closer to the true probability distribution, which would be a nice, well, not continuous curve since we only have discrete outcomes, but there would be a nice curve that you could draw that would connect the tops of the bars. And here we go. There it is. And so that is probably the best estimate that we're going to get, at least in a reasonable amount of time, for how likely these events are. And so based on this, so I just did 10,000 experiments. It looks like it took for 7 cards. We drew our second king on the 7th draw around just under 700 times, which means if you took 700 divided by 10,000, that would give you an estimate for the probability of getting your second king or queen on the 7th draw. All right, so there's 2 examples of creating Monte Carlo simulations. And then we'll actually look at how we can use this sort of notion to describe random processes like the discrete dynamical systems that we studied earlier in the semester in the next batch of videos.